Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today I will be solving next permutation. So what does the question say? A permutation is given. Okay, we all know what is a permutation. So we have to find just the next permutation. Okay, so given an array integer nums, find the next permutation of nums and we have to do this in place. Okay, so basically what's the question is saying that suppose we are given any permutation, let's say 1 2 3. So we have to just return the next permutation, that is 1 3 2. Okay, and if its next permutation will be 1 3 2 and 1 3 2's next permutation will be 2 1 3. Okay, so similarly this way this next permutation will be 2 3 1. So a number is given, an array is given, we have to find the next permutation. Okay, so the most brute force approach which can come in my mind is that we find all the possible permutations of the given array and go into that uh, array or into that resultant, we can say if we resultant superset. Okay, and we find the input which we are given nums. Okay, and we just return the next set. Okay, I mean the most brute force approach is for finding all the possible permutation. How many possible permutations can be there? If a nums array is given of size n, then possible permutations can be n factorial. Okay, now I'm saying if it is in sorted order, we can easily find the next permutation. So this will take approx time complexity of n factorial into n. This will be very huge time complexity, so this is not accepted. Okay, now the next approach which can come into my mind is the STL function which we can use. So STL function is very easy. STL function says that just perform the next permutation. We have STL function in C++. Okay, we can just use it. So this way we can use this STL function. Okay, now we don't have to return anything. So if I submit it, so this will pass all the test cases because we have an STL function here. But this question says that we have to find the next permutation. It's a better approach, but it's not accepted. The interviewer will say that we have to implement it. Okay, so now how we can do this? Let's reset it first. So now I will tell you what can be the possible idea. Let's say our number is given 1 2 3 6 5 4 and we have to find the next permutation for this number. So if we observe, this question is a observation type question, so we have to find the next permutation. So think of it like this: all the numbers, suppose we have a dictionary of numbers. Okay, and we have to find the next number just after this in the dictionary. So we can observe in the dictionary that all the numbers are have a all the numbers which are very closer have a very long prefix match. I mean they have a very long prefix match. Okay, I mean starting from to the mid anything. Okay, so what we will do, we will just try to find the longest prefix match. So for that this is the one observation. Okay, the next thing we can, if we travel, this is an example 1 2 3 6 5 4, and suppose we travel from the back, we can see this is increasing till 6, and this is the breaking point, and from here up to this number 3 we can see this is just decreasing. Okay, so for finding the just next greater number or next permutation, what we can do, what we can think of it, we can think that we should replace this 3 with any larger number. Because suppose if we try to do something here, if we try to make a number slightly greater than 654 among this, using these three numbers, it's not possible because 654 is already the largest possible number among using 6, 5 and 4. So what we will do, we will try to update this 3. So the first thing, we will go and find the number which is just smaller than the next element. Okay, so we have found here 3. Now we have to replace this with a number. So what we can do, uh, we can just replace it with any number which is uh, which which comes after 3. Okay, I mean we have to replace 3 with any number from here, from among 6, 5 and 4, because we because from our observation 1, our longest prefix matches this 1 and 2. Okay, we don't have to touch it. Okay, and we have to find the next permutation, so we will not touch it, we will just update 3. So what we can do, we have to update 3. So from so what we can do to update 3, we can find just we can find a number which is just greater than 3. Okay, just greater than 3. So how can we find the number? So among this, the number is 4. We can, what we can do, we can just iterate from the right, and we can find a number which is greater than 3. Let's say if we iterate here and we find the number greater than 3 is 4, just greater than 3. Okay, this is 4. Now we will replace, or we can say that we can swap it with 4. Okay, this is the breaking point and we will swap it with 4. So the number will be this. So is this number the next permutation? No, because if we update this number and we find in this number after the breaking point, this is not the next permutation. Okay, so what we can do, after updating 3, that is 4, we have to make it smallest. 653, we have to make it smallest. So what we can do, we can just sort it. So after sorting, it will become 356. So but sorting takes n log n time complexity. So we can, what we can do here, we can see if we are swapping any number with 3 which is just greater than the number here from the end, we can see the element, this number 653 is already in descending order. So we can just reverse it and we will find the sorted order. Okay, in the ascending order. So now the number will become 1 2 4 3 5 6, and this number is the next permutation of 1 2 3 6 5 4. So this is the main logic of solving or finding the next permutation. First, we have to iterate from back and find the element which is just smaller than the next element. Secondly, this will be our breaking index. We can say, we can mark this 3 as our breaking index, this index as our breaking point. Okay, now what we will do, we will find a number from the back, from the end, that is just slightly greater than 3, and as whenever we find, we will just swap it and break from there. Okay, we will swap 3 and 4. Okay, we will swap 3 and 4. Now what we can do, we can just this, we can see this is in descending order. We can just reverse from here, from this breaking index. Let's say this is idx, let's say this index will be, breaking index will be idx. So now we will just reverse this array from idx plus 1 to the end. Okay, and now we will get a number 1 or array or permutation as 1 2 4 3 5 6. Now this will solve our question. So if I go to the implementation part, first of all I will find the size of the nums array, nums.size. Now what was our first step? We have to find our breaking index. say our breaking index is -1. Okay, now we will find the breaking index from the back. So I will start from n-2, and I should be greater than equal to 0, and we have to decrease I every time, and any time if I find a number which is smaller than the next number, the right element, we will say we have find our breaking index as I, and I will just break from there. Okay, so we have found our breaking index, but what if we didn't find our breaking index? What if the number is, let's say, what if the number is 6, 5, 4, 3, 2, 1? So what will be the next permutation of this? We are at the end of the dictionary in the lexicographically order. Okay, so we cannot find the next permutation. So according to the question, if we are at the end, what we can do, we can just reverse it and return the very first element, very first permutation of this. So the first permutation will be, the next permutation will be its very first permutation. So we will just reverse it and return it 1, 2, 3, 4, 5, 6. Okay, so we have to handle this case also. So I will say that if we haven't find index, it means that index is still -1. I will say just reverse it, nums dot begin comma nums dot end, just reverse it and return from there. Now if we find our breaking index, what was our next step? Our next step was to find a number which is just greater than the breaking index element from the back. So I will iterate from the back. I is equals to n-1. I should be greater than equal to 0, and I will decrease I. Okay, so if we find any element that is just greater than our breaking index element, so I will say swap it. Let's swap it first, then move ahead. Nums of I with nums of idx, and break from there. Okay, now what was our third step after swapping it? We are here 1, 2, 4, 6, 5, 3. Now we have to reverse also. From where? From idx plus 1. From idx plus 1 up to end. Okay, so and we will return. So here we don't have to return anything. We are just reversing array from idx plus 1 to the end. Now let's submit it with check whether we are able to pass the sample test cases or not. We are able to pass the sample test cases. Now let's submit it and check whether we are able to pass all the test cases or not. So we can see we have passed all the test cases here, and we have solved this problem successfully. And now if I tell you one more thing which we have learned from this question, we are finding here next permutation, and what if the question comes, we have to find the previous permutation. So you can dry run also, but if I tell you the simple trick for finding the previous permutation, we don't have to do anything. It's very simple. We have to just change the sign of this this for loop, and we have to change the sign here, and we will be finding our previous permutation. You can dry run also, but here we are asked to find the next permutation. So uh, we will find here. And if I talk about the time and space complexity, so the time complexity, we are what we are doing, this for loop is going running up n times, and this for loop is running n times, and these reverse function is will also take of n time complexity. So we can say that our time complexity is big O of n. Okay, and our space complexity, we can say technically that it's big O of uh, we are not using any extra space. Okay, we are just doing it in place. We are not using any extra space. We are not declaring any array or anything. Just this, and this will take big O of n. So the space complexity is big O of n. Okay, so that's all for this problem. I hope you understood. Thanks for watching. Till then, keep learning and keep upgrading yourself. See you in the next video.